It means study. Thermo, it means heat. So the key concept is that heat is a form of energy corresponding to a definite amount of mechanical work. So heat was not formally recognized as a form of energy until about 1798, when Count Rumford, a British military engineer, noticed that limitless amounts of heat could be generated in the boring of cannon barrels, and that the amount of heat generated is proportional to the work done in the turning a blunt boring tool. So the Rumford observation of the proportionality between heat generated and work done lies at the foundation of thermodynamics. After the Rumford, Carant's work concerned the limitations on the maximum amount of work that can be obtained from a steam engine. So first Rumford observed in the cannon barrels. The next Carnot's worked on the steam engine operating with a high temperature, so the heat transfers as its driving force. Later that century, these ideas were developed by Rudolf Clausius, a German mathematician and physicist, into the first and second laws of thermodynamics. So entire the thermodynamics, which deals with the heat and energy. So the how the heat transforms one form to another form, how the generates energy. So these are main concepts in the thermodynamics. The most important laws of thermodynamics. So there are most important laws given different scientists in different ways. One is the Zeroth Law of Thermodynamics. Next, first law of thermodynamics, second law of thermodynamics, and the third law of thermodynamics. So in these laws, in our syllabus, they are given first and second laws of thermodynamics. So before discussing the first law of thermodynamics, we know zeroth law of thermodynamics. So what is the zeroth law of thermodynamics? According to zeroth law of thermodynamics, when two systems are each in the thermal equilibrium with a third system of the two systems are thermal equilibrium. So before going to the thermodynamics laws, first we discussed a few terms. One is the energy relations, and the second one is system, surroundings, and processes. First, energy relations. So the first law of thermodynamics involves various energy relations. The forms of energy can be classified into two groups. They are mainly first group related to the system, and the second group is associated with the process. So the energy classified into two groups. First one is the energy related to the system, and second one energy processes, and the second one system. What is system? It refers to a substance or a group of substances set apart for study. So this is energy possessed by material of the system. So that is a system. And next, surroundings. Energy transferred by the processing. So that is called surroundings. So these are the basic terms before going to the thermodynamics laws. So now the energy of the system plus energy of the surroundings is equal to 0. So internal energy, what is the internal energy? Energy of the system plus energy of the surroundings. Means when measured a amount of water in an insulated container is agitated with a rotary stirrer, a definite amount of work is done for every degree of temperature rise due to stirring. So the internal energy of substances does not include any energy that it may possess as a result of its position or movement as a whole. Rather, it refers to the energy of the molecules making of the substance. The recognition of heat and internal energy as form of energy suggests a generalization of the law of conservation of energy. So the first law of thermodynamics applies to the system and surroundings. So the most important laws, they are given the Zeroth Law of Thermodynamics. This is first one. Second one, the first law of thermodynamics. Next, the second law of thermodynamics, and the third law of thermodynamics. In that, Zeroth Law of Thermodynamics, two systems, thermal equilibrium. When the two systems are in the thermal equilibrium with each other, Now the first law of thermodynamics, it is also called as the law of conservation of energy. The change in a system's internal energy is equal to the difference between heat added to the system from its surroundings. So internal energy is equal to the difference between heat and the surroundings, and work done by the system on its surroundings. So first law states that the energy transfers from system to surroundings. So energy, heat energy. So there is heat is a energy. So this is brief explanation, sorry, brief definition of the first law. Now you see the second law of thermodynamics. So the second law states that heat does not flow spontaneously from a colder region to a hotter region, or equivalently. So second law, what is stated that heat does not flow spontaneously from a colder region to hotter region. But the first law states that heat added to the system from its surroundings. So in this second law, the entropy of a closed system or a heat energy for a unit temperature. So it increases over time toward some maximum value. Thus, all closed systems tend toward an equilibrium state in which entropy is at a maximum and no energy is available to do useful work. So first law completely states that open system, how the heat energy transforms from one to another. The second law, it indicates closed system. So closed system, so in this closed system, we are discussed entropy. First law, enthalpy, and the second law, entropy. Now you see the first law of thermodynamics. So this first law of thermodynamics. So the first law of thermodynamics is also known as law of conservation of energy. So this first law states that energy can neither be created nor destroyed. So this energy can only be transferred from one form to another. So they are given an example. Turning on a light would seem to produce energy. However, it is electrical energy that is converted. A way of expressing the first law of thermodynamics is that any change in the internal energy, it indicates a symbol that is delta E of a system, is given by the sum of the heat energy. Heat, it is denoted by Q. So this heat flows across its boundaries. The work that is denoted by W. So the work done on the system by surroundings. Entire the first law delta E, delta E. What is the delta E? Internal energy. Delta E is equal to Q plus W. Heat plus work. A combination of heat and work. So that is internal energy. The internal energy indicates delta E.
Good afternoon, sir. Sir, voice is not audible, sir.
Sir is muted.
Hello?
Hello.
Hello?
Hello.
Hello, sir.
It is audible?
Yes,
Yes.
sir. Now audible, sir.
Okay, ma. Sorry. Please. So internal energy. So what is internal energy? In previous slide, they are given internal energy delta E. So what is delta E? Heat plus work. It is a combination of heat and work. So this internal energy, it is a thermodynamic property of the system. Thermodynamic property. The energy associated with the molecules of the system, that is mainly kinetic and potential energy. You see, so this is the first law of thermodynamics. In this image, they are given two images, state 1 and state 2. Q symbol, it is indicates heat. So this heat transfers, they are given arrow mark, state 1 to state 2. So internal energy, how to calculate internal energy? So this energy transformed to state 1 to state 2. Now the internal energy is equal to E2 minus E1. E2 minus E1 are also Q minus W, heat minus work. So first law, what is states that energy transformed to one place to another place and one form to another form. You see, this energy transformed to one place to another place. So internal energy, capital E, is equal to, in this image, E2 minus E1. E2 minus E1 or Q minus W. So the thermodynamic system is an equilibrium. Possesses a state variable that is known as internal energy. Internal energy, capital E. See, in this first law, heat is a form of energy. Heat, it is denoted the symbol that is Q. Sorry, Q. Heat is denoted a symbol Q. And the energy is nothing but internal energy E. So heat is a form of energy. What this is in first law of thermodynamics, heat is a form of energy. The thermodynamic processes are therefore subject to the principle of conservation of energy. It means heat energy cannot be created or destroyed. Simple definition of first law of thermodynamics, that is that heat is nothing but energy. Energy cannot be created or destroyed. It can be transferred from one location to another location and converted to form different forms of energy. Energy, heat energy. Heat cannot be created nor destroyed. It can be transferred one location to another location and one form to another form. You see the first law of thermodynamics, the equation delta U is equal to Q plus W. Delta U. What is delta U? Change in the internal energy of the system. Only internal energy of the system that indicates a symbol delta E, but delta U indicates change in internal energy of the system. And the Q, heat transferred between system and surroundings. Already, you know, Q, it is a symbol of heat. So heat transfer between system and surroundings. Next, W, work. Work interaction of the system with its surroundings. You see, in this image, they are given delta U is equal to Q minus W plus energy. Now the second image, delta U is equal to stored food energy. In first image, the food is taken work and heat, work and heat. So these, so please mute your phones. So these Q and W, these two are depend upon this delta U. Delta U, it means this is food. So that is why they are given Q minus W plus food energy. Food energy, heat. So this is heat, metabolic activities, that is heat energy. So this heat energy transferred to W, work energy. It means this is a destructive pathway like respiration and releases of ATP. So that is why delta U is equal to Q minus W. But this is anabolic pathway, it means constructive pathway. It means generation of energy. So that energy stored food energy, delta E. Hello, everyone. It is audible. Hello.
Yes, sir.
Yes, sir. Yes.
Okay. So you see, delta U is equal to Q minus W. Q minus W. You see enthalpy, next enthalpy. Enthalpy. H, enthalpy denoted a symbol of H. H is equal to U plus PV. P, it means pressure. V, it is a volume. Already do you know? U, internal energy. Enthalpy, H is equal to internal energy plus pressure and volume. So enthalpy is measurable so the Q is equal to delta U plus P delta V. So enthalpy. So enthalpy is a property of thermodynamic system. It means the sum of internal energy and the product of its pressure and volume. So it is a chemical or biological or physical systems at a constant pressure. So H is equal to E plus PV. E plus PV or U plus PV. H, it means enthalpy, and internal energy U, and P and V, these are pressure and volume.
Volume.
So this enthalpy is not measured directly. The change in enthalpy, is denoted a symbol of delta H. Delta H, it means change in enthalpy. So this delta H is equal to delta U plus delta PV. Generally, the enthalpy equation is H is equal to U plus PV. Change in enthalpy, it means delta H is equal to delta U plus delta PV. So that is enthalpy. Now the see brief discussion. What is the first law of thermodynamics? So this is a definition. The first law of thermodynamics, what is stated that the quantity of the heat absorbed when some amount of heat is given to a system that is capable of doing external work is equal to the sum of the increase in internal energy of the system due to a rise in temperature and external work done during expansion. In examination point, so this is main important. So this is the definition, and the first law, what is stated that delta U is equal to Q minus W. Delta U is equal to Q minus W. So delta Q, it means heat given to the system. W, work
Excuse
done
me,
on the
sir.
system. Okay.
Sir,
W delta U is equal to U. Is W delta U
W-
is equal to U?
wait. W equal to work. Okay.
Yes, sir.
Delta W is equal to delta W. It means change in work. Okay.
Yes, sir.
That is delta W.
Delta W.
Same. Q is equal to Q is equal to heat. Okay.
Heat.
The
Yes, sir.
same delta Q. Delta Q is equal to
Change in heat.
change in heat. Okay.
Yes.
Delta
Yes,
Q
sir.
is equal to change in heat.
Change in.
Then next, capital E, it indicates internal energy. Delta
Yes, sir.
E, change in internal
Internal
energy
energy.
of the system. Okay.
Okay. Okay.
Next, significance of first law of thermodynamics. Significance and what is the significance of first law? They are given applications of first law of thermodynamics. It is also important. In examination oriented, the important question, the one is the first law and the second law. In first law of thermodynamics, in first law, long answer question, discuss the concept of first and second laws of thermodynamics, or write an essay of second law of thermodynamics and its applications, and also write an essay on first law of thermodynamics and applications. If they ask significance and applications, you write this one, significance, first law. One is the relation between heat and work is established by the first law. So entire the first law states that heat and work. So this both work and heat are equivalent to each other. So the exact equivalent amount of energy of the surrounding will be lost or gained if any system gains or loses energy. And one more significant, they are given, applied heat is always equal to the sum of the work done and the change in internal energy. And the energy is constant for isolated system. So applications, first application, the first law of thermodynamics is usually commonly used in heat engines. Next, refrigerators and sweating is a great example. First law of thermodynamics. Next, ice cubes is put in a drink. The ice cubes absorbs heat. Drink which makes it cool. So these are the application, significance and application. Next, second law. It is also important. Second law. In the second law, entropy, total disorderness of a system, that is called entropy. The second law of thermodynamics states that entropy of any isolated systems, entropy always increases. As in first law, the heat content of a system, it is increases or decreases. As in the second law of thermodynamics, entropy is always increases. So as in second law, as in second law, isolated systems spontaneously evolve towards thermal equilibrium. They are given in the third point. A simple way to think second law of thermodynamics is that a room, if not cleaned and tidied, will invariably become more messy and disorderly with time, regardless of how careful one is to keep it clean. When the room is cleaned, its entropy decreases, but the effort to clean it has resulted in an increase in entropy outside the room that is exceeds the entropy lost. So the simple definition of entropy, that is total disorderness of a system, that is called as entropy. So in this second law, what is states that when a hot object comes into contact with a cold object, hot object comes into contact with a cold object, the heat flows from the hotter to the colder, but never from colder to hotter spontaneously. It means energy may still be conserved if heat left the cooler object. So this is second law. The second law of thermodynamics states that entropy of an isolated system can never decrease over time and is constant if and only if all processes are reversible in a nature. Second law, next, Gibbs free energy. Gibbs free energy. So Gibbs free energy symbol is capital G. Capital G. Hello? Hello?
Yes, sir.
Tell me, ma.
Nothing, sir.
Okay. So next, Gibbs free energy. So Gibbs free energy, so Gibbs free energy is not given. Okay. So it is also one of the important gives free energy. So gives free energy. It is based on thermodynamics two laws, like 1 and 2. You see delta G. G it means free energy. Delta G change in free energy is equal to delta H minus delta T and S. So it is a basic formula of gives free energy. So in this topic, there are main concepts are: one is the first law and its significance and applications. The same second law and its applications. These only two questions are given in the first unit, and these two are very, very important questions. Next, second unit, enzymes. 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 What is the enzyme and what are the important role in enzymes? One second.
Enzymes.
The class is over.
Wait.
Okay, sir.
Class is over, sir. Hello.
Hello.
Class is over, sir.
See, this is enzymes. Second topic, enzymes.
Okay.
See, there are different enzymes are there. One is the alkaline phosphatase, glucose oxidase, hemoglobin, horseradish peroxidase, alcoholic dehydrogenase, and xanthine oxidase, urease, cholesterol oxidase, glutamate oxidase, and lactase. You see this image, all the enzymes. How to identify this is enzyme? Enzymes always ends with S. A-S-E. Okay. Enzymes always ends with S.
Suffix.
So what is the enzymes?
Enzymes are nothing but proteins.
Very good. Enzymes are nothing but proteins. You see, that is why in this image all are ends with S except hemoglobin. It means hemoglobin is a
Human
hemoglobin. It is a protein.
protein.
Okay. Hemoglobin, which is made up with protein. It means all the enzymes are proteins. So these enzymes are the biocatalysts. Catalyst. What is mean by catalyst?
Which increases the rate of the reaction, but which is
Right.
not involved in the reaction.
So it is a increases in the rate of
Reaction.
reaction. For example, the student and teacher. It is a good example for the catalyst. The students often find it difficult to learn from a textbook on their own, but the teacher explains the subject to the students and increases their understanding capability. It is a good example for the catalysts. So these enzyme, the word derived from the Greek word enzyme. It is a Greek word. In Greek, enzyme, it means yeast. So the first enzymes discovered in the yeast organism. Yeast, it is a fungal member. So the first
enzyme of natural yeast.
okay, this is enzymes. It is a Greek word. En and zyma. It is a combination of two words, en and zyma. En, it means in,
Right.
and zyma, it means yeast. So first discovered enzymes are in the yeast. And all the enzymes are proteinaceous substances and which are capable of catalyzing chemical reactions of biological origins. So all the enzymes are biocatalysts. And the enzymes exist inside the cell in a colloidal form. An enzyme may be defined as a protein that enhances the rate of biological reactions. It means the enzyme is a protein that enhances the rate of biochemical reactions, but does not affect the nature of final product. So all components of a cell, including cell wall and cell membranes, have enzymes. Maximum 70% of the enzymes in the cell are found in mitochondrion. Means majority of the enzymes in a cell are present in a cell organelle, that is namely mitochondrion. The enzymes are also called as biological middleman. And the study of enzymes is called enzymology. The term enzyme was first used by Kuhne in 1878. Kuhne in 1878. So this is the brief introduction about the enzyme. In next class, we have discussed what is the nature of enzymes and the properties and classification. Thank you.
Class completed. Hello everyone. Hello.
Completed?
Class completed?
I'm asking you only.
Oh, sure. Sir is not there. Participants.
Are here.
Ah.
Then shall we leave or like that only? I think all subjects are finished now.
Timing 4:30 C4?
Only up to 4.
4:15. That's 15 minutes.
Up
Yeah,
to
by
4
that
only.
time, friends, humble request that those who have attended first and second lecture also, if possible, can you share the important questions in the group? That would be really helpful.
Questions are
Means
not
we all
given
can
now.
share in the group, so that will help us in studying. I'm also student. Can we do so?
Questions are not given, no. Just they are explain the topic.
Explain lesson. Lesson wise, important questions explain.
Okay. And during offline lectures, if you have attended, because I am from Goa, so I am not able to attend offline lectures. So during offline lectures, if any important is given, possibly kindly share. It will be great help.
C1, C4, today start classes.
Pardon, C1
C1,
C4.
C4, today start.
start.
Offline
Okay.
classes only C2, C3.
Okay. Acha.
First class is C1 or C4.
Okay. Thank you, ma'am.
Okay.
Then we leave the meeting or no need? Hello?
Hello?
I think class is not there. All subjects are finished now.
Okay, yes, done. 4:16 time is over.
Time is over and explanation of 4 subjects also over, no?
Thermodynamics first topic is completed. Second, enzymes are starting.
Enzymes, he is telling that continue for second. Next class he told, no?
Next class enzyme continue answer.
Then he said thank you also. Then it is,
Sir, no information.
he leave, no, he said thank you.
Okay. No. You, sir, information is no antunna.
సారు థ్యాంక్ యూ అని చెప్పేసి వెళ్ళారండి.
చెప్పేశారా సార్?
థ్యాంక్ యూ
Yes,
అన్నారు.
he given clear in thanks అని చెప్పిండు. నెక్స్ట్ టైం
క్లాస్ లో
ఎంజైమ్స్ గురించి
enzyme
ఎక్స్ప్లెయిన్ చేస్తా మిగిలింది అని చెప్పేసి థ్యాంక్ యూ అని చెప్పేసి వెళ్ళిపోయారు.
ఓకే, అయితే ఆల్ ఆర్ క్లాసెస్ ఫినిష్.
ఫినిష్.
ఓకే, 4 classes are finished.
Yes.
All are submitted your assignments?
Submitted is not.
No.
Time is no their group में April 30th अनर.
Yesterday only.
Before practical exams.
Before May 20 they said no.
May 20.
Before practicals or exams submitted.
May 20 this.
All of you finish assignments?
No, not yet started. Some people not yet started.
No, madam.
Completed.
Completed and submission also.
I have doubt, ma'am.
What?
Submission are completed,
Completed and submitted.
Any more important question on this C4 questions, ma'am?
C4 questions. Assignment questions?
Not assignments in the examination for any important questions. Essay and the short.
No.
Just
Sir.
now he informed, no? Sir informed, no?
No, sir.
First
First
chapter.
class.
But it is not understanding, no?
Yeah, that's what not understand. That's why I'm asking
Nothing
again.
understand. Just he is continuing by reading the From reader itself, it is not there what he taught.
From Google, he was searching and telling that it's explanation.
But in reader, it is difference, no?
Sir
Yeah,
left.
yeah, that too. That
Sir has
too.
already left.
No one is not asking. I'm also sitting like that only. In reader, it is somewhat different, but he
Yeah,
is explaining continuous.
yeah.
What could we say? This is very hot topic. It seems to be like that only.
Excuse me, guys.
Ah,
Sir had already been left.
Yeah, that too I'm saying the sir was not there.
Okay.
Only students are there, this all.
Yes, yes.
Oh my god.
What
So how we will
about
have
your
to
assignments?
Like that.
so doubt how we should clear
doubt.
We should
in
clear
this
ourselves.
in the C4 any more important questions or anything else or in the for exam and the
First,
assignments
let
also.
us to understand the topic.
And then
If he said
No
questions
doubt,
also,
yeah, we have to understand in the topic, but also we can in the reader we have to see and
in the
if
next
we
class we should ask.
okay fine,
ah,
okay fine. If we see in the
all are
reader also,
same problem, no? All
yeah,
are
that
getting
too.
same, no?
All have same problem.
But no one open mouth. Just I am also in middle. If we ask middle, he can get anger, no?
Yeah, that
That's why
was
we're
I
not
didn't ask.
asking.
He is
Ah,
interestingly explaining what he is explaining. I don't understand. First of all, nothing is there top in the reader itself. First he
Acha,
entered.
what about the second class? What about the second class, the Bryophyta? About the Bryophyta?
Bryophyta is
Everybody,
good.
what he taught?
Bryophyta is good.
Markandeya.
Bryophyta and madam explained also
No,
good.
no, ma'am.
No, Bryophyta
Kumar
is
sir,
good.
Kumar sir.
That is
Kumar sir.
Markancha about Bryophyta.
Everybody understood what he taught.
Kumar sir.
It is just familiar.
Kumar sir
It
and
is
Sudha
good.
ma'am's class was good. What they will explain?
Ma'am, Sudha ma'am's class was good, and that
And
Prabhakar's
she
class
advised
was good.
also very good as no. No need
Yeah,
to worry about total lengthy chapters or no need to read.
yeah. She
She
told,
well she
she told that
advised well.
anatomy, you concentrate on anatomy unit or taxonomy.
Taxonomy.
Only two units you can revise or
She advised nice, no remaining.
yeah. I too like that. Ma'am told.
Really, it was nice.
From
And
before she was telling like this only. From before starting classes, offline classes also she explained like this only. Very nice.
ah,
Before online